Past few years brought some informal news for all the exoplanet cognoscentes out there. According to the Planetary Habitability Laboratory at the University of Puerto Rico at Arecibo, there are verily 30 other potentially habitable exoplanets. Some of those are close to Earth's size. Many are much larger. And none of them is remotely like Earth. If there's life on those planets, it's probably just surface microbes that still have a few billion years of evolving to do. For Earthlings to survive on those worlds, they'll need a lot of new technology that hasn't been invented yet, as well as a little bit of luck. And this is only possible in my imaginations. Exoplanet researchers use something called the Earth Similarity Index to dispose how closely an exoplanet or other object in space, like a moon, dwarf planet, or asteroid, resembles Earth. Each object is given a rating on a scale of 0 to 1, with 1 being Earth, that takes into account a planet's size, density, escape velocity, and surface temperature. We have a lot more to learn about all of them, and like Kepler 438b, many will turn out to have simply been a satirize, but here are the 5 most habitable exoplanets we know about so far, according to their ESI ranking. Humans had better snatch up these properties soon before someone else does. A couple of notes before we begin: we're only looking at objects that have been confirmed as exoplanets, so no candidates still waiting for approval. And we're only looking at planets. No moons or dwarfs or other objects trying masquerade as something they're not. Glial 667 cc, ESI 0.84. Just a more 23.62 light-years away, Glial 667 cc is floating around in a triple star system in the constellation Scorpius. Discovered in 2011, scientists think the exoplanet receives about 90% of the light that Earth does, but that's not the full story. Glial 667 cc star is an M-class star. A red little thing that burns about 2,200 degrees Celsius less than our own G-class sun. Much of what would get to the exoplanet is infrared light. Translation: Glial 667 cc only gets about 20% of the visible light Earth does, making it a much darker and colder planet. By no means, however, does that mean it's too cold. In fact, Glial 667 c seems to get a little more electromagnetic radiation than Earth, so it's actually a little hotter. Plants won't grow super well due to a lack in visible light, but some hardy vegetables that prefer the shade might do well. For now, it doesn't seem to have a dangerous atmosphere. Its mass is estimated to be about 3.8 times that of Earth's. Kepler 442b, ESI 0.84. The crucial difference between this exoplanet and GJ 667 cc here is in the stars. Kepler 442b has a K-class star, which is just about 750 degrees Celsius colder than the Sun, though it will probably live longer, and smaller too. That might be cause for concern. Smaller stars sometimes produce stronger solar winds, and so if Kepler 442 doesn't have a good magnetic field to shield itself from all of that violent energy, there's no chance it could sustain life. However, if the star turns out to be stable, this could be a great place to settle down and grow some crops. Physically, Kepler 442b is just 2.34 times the mass of Earth, making the surface gravity 30% stronger, which tolerable for humans to get used to. The biggest mark against Kepler 442b is that it's 1,120 light-years away from Earth, in the constellation Lyra. Anyone moving here shouldn't plan on having their friends and family over anytime soon. Kepler 62e, ESI 0.83. Kepler 62e and Kepler 442b are like siblings. Both orbit K-class stars that could give them a high potential for sustaining plant life. Both exist in the constellation Lyra. But there's kind of where the similarities end. There's a big chance Kepler 62e could be covered in water ice, great for anyone that wants to pretend to be living in Kevin Costner's Waterworld. Bad news for anyone who doesn't like to reenact shitty movies. The Superterran exoplanet is about 60% larger than Earth, but it's unclear what the density of planet is, so we can't yet calculate the mass. Chances are, however, that the planet has a substantially higher gravity than Earth's. Most unfortunately, Kepler 62e is more than almost 1,200 light-years away from that compared to Kepler 452b, ESI 0.83. A horrendous 1,402.5 light-years away from Earth, Kepler 452b has one thing going for it no other planet on this list has, a G-class star. That might be well worth the trip, since the planet gets 10% more energy from its star than we do here from our host star. Habitation would thrive here. That's assuming it has an atmosphere that'd fostered a relatively stable climate, and not a runaway greenhouse effect like we see on Venus. Still, Kepler 452b has a mass that's probably 5 times larger than Earth's, and a gravity that's twice as powerful. We're not even completely sure if it's a rocky planet, though if it is, it might have some volatile geological activity because of an increased mass and density. Glial 832, ESI 0.81. Another one orbiting an M-class star, Glial 832 lives in a neighborhood just 16.2 light-years away, in the constellation Grus. It gets approximately the same amount of energy from its star that Earth does from the Sun, and its predicted temperature is actually pretty similar to Earth's, or at least it would if it didn't have an eccentric orbit that creates potentially drastic temperature swings. Speaking of which, that orbit is just 36 Earth days, so at least you can enjoy making and breaking New Year's resolutions about every 5 weeks. Glial 832's mass, however, is about 5.4 times that of Earth's. Not much is known about the atmosphere, so gravity notwithstanding, it could be the closest thing Earth has to a long-lost twin, or it could be another beacon of false hope. 1.